Kirchhoff's rules are named after a German physicist, Gustav Kirchhoff, who outlined a systematic way of solving multi-loop circuits. Kirchhoff's rule comprises of two rules. First is junction rule states that the sum of the current at a junction must equal to the sum of all currents leaving the junction. So we have summation current moving in a junction and the sum of the current moving out the junction are equal. Okay, for example, we have a junction here. If I1 is entering the junction, I2 is leaving the junction, and also I3. This is I1, I2, and I3. Therefore, I1 is equal to I2 plus I3. Next, let's proceed to the second rule. Loop rule states that the algebraic sum of charges in the potential around enclosed circuit path or loop must be equal to 0. Okay, so the summation of V is equal to 0 since we are talking about the potential. Now, let's have an example using the junction rule and the loop rule. Example number 1, identify the different current flowing in the circuit. So this is our circuit. First, let's identify the current flows in each resistor. So the current that is flowing in R1 is I1, in R2 is I2, and in R3 is I3. Okay, let's enlarge this portion here since the junction is here. So we have our enlarged version. So the junction rule states that the sum of the current entering a junction, the summation of current entering the junction is equal to the sum of the current leaving the junction. Okay, so I1 is entering the junction and I2 and I3 are leaving the junction. Okay, so now I1 is equal to the sum of I2 plus I3. Okay, so this is now our first equation. Okay, next, let's consider our loop rule. It states that V, or the summation of V, is equal to 0, or it must add up to 0. Okay, let's proceed. Now you need to determine which element will create a voltage lift or a positive voltage contribution, or which one will create a voltage drop or a negative contribution to the voltage of the circuit. If a potential is traveling from higher to lower concentration, it will create a voltage or a negative voltage. But if a potential is traveling from lower to higher concentration, it will create a positive voltage. Okay, next, if a current is flowing from this direction, and let's label this as letter A and letter B for comparison. And we all know that current is flowing from positive to negative, positive to negative. Okay, in letter A, the loop is traveling from negative to positive. Okay, it will create a positive voltage contribution. But if the loop is traveling from positive to negative, it will create a negative voltage contribution. Okay? So, next we have a resistor. Okay, if our resistor is like this and this is the positive and negative terminal. If the loop is traveling from this path, so from negative to positive, there is a voltage lift, so it will create a positive voltage contribution. Okay, but if a resistor, this is the positive terminal and negative terminal. If the loop is traveling from this direction, so from positive to negative, it will have or it will create a voltage drop or a negative voltage contribution. Example number 1, identify the different current flowing in the circuit. Okay, so first let's draw the direction of the loop. This is loop 1 and this is loop 2. Okay, so first let's focus on loop 1. Okay, so direction of the loop in this battery is from negative to positive. So it creates a positive voltage contribution. So let's write positive 24 here, and then going to this resistor from positive to negative, that creates a negative voltage contribution. So 3 multiplied by I1 is equal to 3I1. So let's write negative 3I1 here. And then going to this resistor from positive to negative, so it creates a negative contribution. So let's multiply 4. Let's write negative here. 4 multiplied by I2 is 4I2 is equal to 0. Okay, so let's move negative I1 minus 4I2 dito sa kabila. So 24 is equal to 3I1 plus 4I2. Okay, so I already mentioned that I1 is equal to I2 plus I3. Okay, so let's substitute this dito sa may I1. So 24 is equal to 3 multiplied by I2 plus I3 plus 4I2. Okay, let's distribute 3. So 24 is equal to 3I2 plus I3, 3I3, sorry, plus 4I2. Okay, so there are two like terms here. So let's add 3I2 plus 4I2. So magiging 24 is equal to 3 plus 4 is equal to 7. I2 plus 3I3. Okay, so this is our first equation. Next, let's proceed to loop 2. Loop 2. Okay, loop 2, the direction of the loop is in this resistor is from negative to positive. So it creates a positive voltage contribution. So let's write positive 4I2. And then going to this resistor from positive to negative. So it creates a negative voltage contribution. So let's write negative 12 multiplied by I3 is 12. I3 is equal to 0. Or let's rewrite 0 is equal to 4I2 minus 12I3. Okay, let's rewrite loop 1. 24 is equal to 7. I2 plus 3I3. And then loop 2 is equal to 0 is equal to 4I2 minus 12I3. Okay, in order to cancel from loop 1 and loop 2, let's multiply loop 2 to 1/4. Okay, ma'am, bakit po 1/4? Okay, so that 12 multiplied by 1/4 is 3. So that we can cancel positive 3I3 here and negative 3I3 here. Okay, so 1/4. So 0 multiplied by 1/4 is 0. And 1/4 multiplied by 4I2 is 1I2 minus 12 multiplied by 1/4 is 3I3. Okay, so let's add the two equations. So 24 is equal to 7I2 plus 3I3 plus 0 is equal to 1I2 minus 3I3. Okay, let's add. Let's cancel this first. 24 plus 0 is 24. 7I2 plus 1I2 is 8I2. Okay, in order to cancel or in order for I2 to be remained, let's multiply both sides to 8. Cancel, cancel. I2 now is equal to 24 divided by 8 is, okay, very good, 3 amp. Okay, so the value of our I2 is 3 amp. Okay, let's use this equation in solving I3. This equation. So we have 0 is equal to 1I2 minus 3I3. Okay, 0 is equal to 1 multiplied by 3 is equal minus 3I3. Okay, let's move this doon sa kabila. 3I3 is equal to 3 amp. Okay, divide both side by 3 in there. So 3I3 is equal to 3 amp So let's divide both sides by 3. So 3 divided by 3 is equal to 1 amp. Okay, so our I3 now is 1 amp. Okay, we already said that 1 I1 is equal to 1 I2 plus 1 I3. Okay, let's just add I2, which is 3 amp, plus I3 is 1 amp. Okay, so 3 plus 1 is equal to 4 amp. Okay, so the value of our I1 now is 4 amp. Okay, so our I1 is 4 amp and our I2 is 3 amp and our I3 is 1 amp. Okay, let's proceed to example number 2. Example number 2, identify the different current flowing in this circuit. So in this circuit, we have two batteries, one with 9 volts and another with 1.5 volts. So let's identify the positive and the negative terminal of the batteries. Okay, so ma'am, how can we identify if that is the positive or the negative terminal of the battery? So in the figure, the longer, that is the positive terminal, and the shorter, that is the negative terminal of the battery. Okay, next, let's identify the different currents flowing in this circuit. So let's write here current 1 or I1 that enters the junction, and there are two currents that leaves the junction, that is I2 and I3. Okay, so we already mentioned that currents or current flows from positive to negative. Positive to negative. Okay, let's draw the direction of our loop here. Okay, so we have loop 1 and loop 1 and loop 2. Okay, so first let's focus on loop 1. In loop 1, we have, in this battery, the direction is of the loop is from negative to positive, and that means it creates a positive voltage contribution. So let's write positive here. Going to this resistor from positive to negative, so it creates a negative voltage contribution, so minus 100 I2. Next is equal to 0. Now let's move negative 100 I2 here. So let's rewrite positive 9 is equal to positive 100 I2. Okay, let's divide both sides by 100. Cancel, cancel. So I2 now is equal to 9 divided by 100 is 0.09 ampere. Okay, next let's proceed to loop 2. Okay, so our I2 now is 0.09 amperes. Okay, next loop 2. Loop 2 is, okay, let's start here in this battery. So direction of the loop is from negative to positive. Okay, so that creates a negative or positive. Okay, a positive voltage contribution. So let's write positive 1.5 here, then the loop's direction going to this resistor from negative to positive, so that creates a positive voltage contribution. So we have positive 100 I2, and then going to this resistor from positive to negative, so that creates a negative voltage contribution, let's write negative 200 I3 is equal to 0. Okay, let's move positive 100 I2 minus 200 I3 here. So let's rewrite 1.5 plus, 1.5 is equal to, wait, let's erase. 1.5 now is equal to negative 100 I2 plus 200 I3. Okay, so since we have the value of I2 which is 0.09, so ilagay natin yung 0.09 dito sa may I2. So we have 1.5 is equal to negative 100 multiply by 0.09 amperes plus 200 I3. Okay, negative 100 multiplied by 0.09 is negative 9. So 1.5 is equal to negative 9 plus amperes, so plus 200 I3. Okay, let's move this here. 1.5 plus 9 amp is equal to 200 I3. Okay. I-move natin dito. So, 9 plus 1.5 is equal to 10.5 amperes is equal to 200 I3. Let's divide both sides by 200. Cancel. So, 10.5 divided by 200 is equal to, okay, very good, 0.05. Let's continue. Our I2 now is equal to 0.09 and our I3 is equal to 0.05. So, I already mentioned that I1 is equal to I2 plus I3. So, let's add 0.09 and 0.05. So, our I1 now is equal to, kindly compute 0.09 plus 0.05 is 0.14. So, our I1 is 0.14. So let's write I1 0.14. So these are the different currents flowing in this circuit. Okay, now let's proceed to example number 3. Example number 3, identify the different current flowing in the circuit. Okay, so again, this is the positive terminal, the negative terminal, the current. Okay, let's identify the current. So this is current number 1 that enters from positive to negative terminal of this resistor. And then I1 that enters this junction, and I2 and I3 that leaves the direction. So we have positive, negative, positive, negative. Okay, so let's draw the direction of the loop. Okay, so now let's proceed to loop 1, or let's focus on loop number 1. Okay, loop number 1's direction in this battery is from negative to positive. So it creates a positive voltage contribution. So let's write positive 54 here. Then going to this resistor from positive to negative. So it creates a negative voltage contribution, or a voltage drop, minus 6 I1 going to this resistor from positive to negative, that creates a negative voltage contribution. So let's write negative 8I2 is equal to 0. Okay, so let's move negative 6I1 minus 8I2 here. So 54 is equal to positive 6I1 plus 8I2. Okay, so again, let's substitute the value of I, which is I2, 6 multiplied by I2 plus I3, 54, plus 8I2. Okay, let's distribute. 54 now is equal to 6I2 plus I3 plus 6I3 plus 8I2. Okay, so there are like terms. So let's add 6I2 plus 8I2. So 54 is equal to 6 plus 8I2 is, okay, very good, 14I2 plus 6I3. Okay, so this is our first equation. Okay, let's proceed to loop 2. Okay, let's continue here in loop 2, traveling in this direction. So we have I2 and I3. I is traveling from positive to negative, positive to negative. So let's try loop 2. So the direction of the loop is from negative to positive in this resistor. So it creates a positive voltage contribution. So let's write 8 positive 8I2. Then going to this resistor from positive to negative, that is negative voltage contribution. So let's write negative 12I3 is equal to 0. Okay, so this, let's rewrite 0 is equal to 8I2 minus 12I3. So this is the second equation. Okay, the equation in loop 2. Okay, so let's add the equation in loop 2 and loop 3. So we have 54 is equal to 14I2 plus 6I3. Okay, and this in this equation, 0 is equal to 8I2 minus 12I3. Okay, in order to cancel in this two equation, let's multiply 0 is equal to 8I2 minus 12I3 into 1 half. Okay, para maging 6I3 itong 12 dito. So 1 half multiplied by 0 is 0. 1 half multiplied by 8 is equal to 4I2. And minus 1 half multiplied by 12 is 6I3. Okay, so let's erase this. Okay, so let's add 54 is equal to 14I2 plus 6I3 plus 0 is equal to 4I2 minus 6I3. Okay, so let's cancel this. 54 plus 0 is 54. 14 plus 4, I2 is equal to 18. 18 I2. Okay, so let's divide both sides by 18. So, cancel, cancel. I2 now is equal to 54 divided by 18 is 3 amps. Okay, am I correct? 54 divided by 18 is equal to 3. Okay, very good. So we have now I2. Okay, let's proceed to I3. Okay, let's use this equation. 0 is equal to 4I2 minus 6I3. So let's write here. 0 is equal to 4I2 minus 6I3. Okay, so 0 is equal to 4 and the value of I2 is 3 amp minus 6I3. 0 is equal to 4 multiplied by 3 is equal to 12. So 12 amp minus 6I3. Okay, let's move negative 6I3 here. So magiging 6I3 is equal to 12 amp. Let's divide both sides by 6. Cancel, cancel. So 12 divided by 6 is equal to 2 amp. Okay, next and lastly, let's identify I2. Okay, I already mentioned that I1 is equal to I2 plus I3. So let's just add the value of I2, which is 3 amp plus 2 amp is equal to 5 amperes. Okay, so our I1 is our I1 is 5, I2 is 3 amp, and our I3 is 2 amp. Okay, so these are the different currents flowing in this circuit.